Um, Now this 2 meter pipe length or pipe segment length and 12-inch diameter, that is applicable for the this pump suction, total 5 pipe segments. Now we need to keep on editing the other things. So let us select these 5 pipe segments, mirror image of the suction. These pipes are still in the pump house. So the length we'll keep it 5 meters. Yes, Mr. Mark, make it 5 meters.
Okay, so 5 meters.
And the nominal size, since it is pump discharge, it would be lesser than suction. So let us say 8-inch, schedule 40.
8 inch.
Expanded. Okay. All right. Other things we already changed, Hazen Williams and 100. So that is the reason we had selected all the pipes so that we don't have to change it each and every time. Right? You need to save time. Okay. So this part is done. So total 10 pipe segments we are covered. Sorry?
We will change only the discharge piping to 8-inch.
And the length will be 5 meters.
Length. Okay.
All right. Now let us select the headers, which the pipe is already left the building. So 1, 2, 3. These are the cooling water supply header, and this is the cooling water return header, right? So this length would be 50 because it has to travel distance from one unit to the other unit. 50.
50 meters.
Yes, and it will be 8-inch, schedule 40.
Okay.
All right. Now there are total 6 pipe segments around the exchanger. Okay, inlet to exchanger and outlet from the exchanger. So please select those 6 pipes.
The
Exchanger, heat exchanger.
Okay. Inlet and outlets.
Yes, correct. Using the shift key.
Okay.
So this will be 10 meters and 5-inch, schedule 40.
How many inches?
5-inch.
5 inch.
40. Yes.
5 inch is not a standard pipe.
Yeah, but we are going to use that.
Okay. All right.
It's not standard, but still sometimes we use it. Scroll up. Yeah, schedule 40. Then, okay. All right. So piping data also we have provided. If it is completed till this point.
The length is okay, 10 meters?
Yes.
Okay.
If it is done till this point, please type done in the chat box.
Can you show the data on time, sir?
Data, which data?
The 5-inch line data.
Yes. So inlet and outlet will have 10 meter and 5-inch, schedule 40.
Okay, done.
Okay. Now this pipe, okay, this is the pump suction. And this pipe, it is pump discharge. So for the both pipe, I want to know the velocity. So if you go to properties on flow sheet for only for those 2 pipes and make it show. Okay, bottom is fine. The properties. Yes, click there on the right side box. Yes.
It's not showing anything. Okay.
Yeah, yeah.
All right.
All right. So we want the velocity, right? So we have got
Velocity.
in velocity and out velocity in the results. In velocity means inlet of the pipe. Out velocity means outlet of the pipe. So we can select
Sorry.
out pipe. Then click OK.
Let me be sure whether the other one is ticked. The inlet. Inlet velocity. It's not ticked. Okay. All right.
So since it is liquid, in and out will be same.
Yeah.
So we can select only out.
So I can leave the other one.
All right, we can do that. So let us say OK.
All right.
All right, please complete this. Please make sure that you are saving the file in between. Okay, so now just look at Shama's screen.
So what's in the result, sir? How velocity other one is? Result?
Results in velocity and out velocity. Okay.
Velocity non ಇಲ್ಲವೇ ಇಲ್ಲಿ ಇದೆ. Velocity ಏನಿದೆನೋ
Ma'am, are you asking something?
No, sir.
Okay. So for some time, I'm just going to make this hide. Okay, you don't have to do that. All right. Now, if you see this T, first T, it has got this red dot, which is pointing towards pipe number -4. Okay, -4 is the red dot location is towards -4. So that is what is shown here, right? The question is, what is the right location of this red dot? So some help is available. So if you click on the T, then go to the input in the data palette and the nomenclature. There is explanation. Okay. Then click on that. So one window will open. So there are two tabs, combining flow and this dividing flow. Now in this case, this pipe 1 inlet pipe, right? So it is because of the T, the flow is getting combined or divided?
It's divided.
It is divided. So we'll go to second tab. So diverging or dividing flow. In this option also, we have got two options here, T and Y. Now just imagine you have got this header, 12-inch header is there, right? It is traveling horizontally. Now there is this pump A and pump B. So we need to divert this branches to one branch goes to the pump A, other branch goes to the pump B.
Pump B.
So what will the alpha angle? It will be 180.
Yes.
Right? We are not going to take like say a 12-inch header straight pipe like this in T. We are not going to have this 12-inch channel, 12-inch straight pipe, and you are going to take up tapping of 12-inch.
Yeah.
Okay, it is not going to look like that, right? It would be something like Y. Like say channel is there, 12-inch pipe is there, and we have got two branches of, and the alpha is, it is symmetric. So our system represents T or Y.
Okay.
Okay, it represents Y. So in Y, the red dot should be towards pipe number 1, inlet to the T. So we need to correct the red dot location. So how to change that? You'll click on the T, then go to this branch pipe. So if you click once, the red dot shifts to the other pipe. If you click again, then it goes to the left side. So this is what we need. So why this is important? Because you are using idle check, and idle check wants this red dot to be specified in a specific way.
Okay.
Okay, then next T. We'll move to the next T. Here also same thing, but in this case, the flow is getting combined. So if I go to the explanation, flow is getting combined. Like say pipe 11 is there, which is coming from pump A. Pipe 12 is there, which is coming from pump B. And because of this T, it is getting combined, and on the right side, it goes out as a common header, right? Now this represents a T or a Y? This system?
Why?
Y only.
It's still a Y.
Because it's
Yeah.
alpha, it is 180 degree would be there, alpha value.
Exactly.
Right? So branch 1, branch 2, and then it becomes this channel. So in this case, the red dot should be towards the header.
Yeah.
Right? Okay. So it's already towards the header, so no need to change there. Correct?
Correct.
Okay. So let me reduce the view a little bit. Okay, let me go up. Now the next T. Okay, I'm just going to change this scheme a little bit. So if you see this pipe 14, it is 8-inch, 15 also 8-inch. Now from this 8-inch straight pipe, we are taking tapping, okay, or this branch of 5-inch, right? And with some
Yeah.
alpha angle, so it could be 90 degree, right? So if I click on this T and again go to the explanation, here flow is getting divided. I'll go to the diverging. Now this system represents what? A Y or a T? You have the channel or this header 14, 8-inch, and it is a straight pipe. From the straight pipe, you are taking 5-inch branch
It's
out.
still a Y. It's still a Y.
No, it is not a Y, it is a T. Because see sir, this 14 number pipe and this 15 number pipe is basically one straight pipe, correct? Which is represented here, channel and straight. It's a straight pipe. From the straight pipe, you are taking, from this 8-inch pipe, you are taking 5-inch branch out.
90 degrees, okay.
Right? So this branch and this straight pipe, they are not symmetric. Clear? So it doesn't represent a Y, it represents a T. So in this case, the red dot should be towards the branch. So what is the branch here? This 5-inch length. So is it correct? So already it is correct. So same funda will be applicable for the combining because the other side also we have got a T. So there also, if it is coming from any branch, then the red dot would be towards the branch. Clear? Okay, let us move to the next T. Here already it is correct. This 8-inch pipe, and then branch is 5-inch. If you go to the other side, this is 8-inch pipe. This is 8-inch pipe, and the branch is 5-inch. So the red dot should be towards the branch because this is a T, not a Y. So how to change that? Click, click. Same goes here for this T. All right. So let me reduce the view again. All right. So everybody has completed till this point. Okay, the table I'll make it show for the pump suction. Yes, Chirag, is it done?
Yes, sir.
All right. So please save this file. Again, all the input. The only thing remaining is click calculate. All right. So everybody, please write the flow rate of the first exchanger.
136.4.
136.4.
Okay, and the second one is
Second one is
86,
86.8.
and the third one is
76.8.
96.8.
okay. But we wanted 100 meter cube per hour, right?
Yes.
Yes.
Okay. So why we are not getting it? Ajay, it should be 136.4. Maybe the input is not correct in your case. Okay, nevertheless, we'll proceed.
But I'm sure the total will give you 300.
It will be 300 because you are telling the pump to push 300.
Mm.
Yes, Madhu ma'am, what do you think? Why the flow rate in the first one is the highest, second one is less, and the third one is the least?
Sir, usually when a flow comes through a pipeline, the first pipeline will have less pressure drop compared to the second one and compared to the third one. So the first one flow will be high, second will be little less than that, third will be little less than that.
Okay, good. So if I consider this rectangle, okay, this loop. So which T or bend has the maximum pressure? The first one.
Yes.
Why? Because it is very close to the pump,
Mm-hmm.
right? Now,
Mm.
while it is going from this T21 to T23, it has to travel this 50-meter distance, right?
Yeah.
So by the time this T is reached, the pressure also has got less. So this second T will have less pressure than the first T, right? And again from this T23, it goes to bend 22. It has to travel again 50 meters. So 22 bend will have less pressure as compared to T number 23.
Yeah.
Right? And it has to travel this 10 meter, then one bar is getting lost in the exchanger. Again, delta P in this 10-meter line. So bend number 26 will have less pressure as compared to bend 22. Now from here, again, 50 meter it has to travel to go from this bend to this T. T number 25 will have less pressure as compared to 26 bend. And while the water is flowing from 25T to 24T, because of the pressure drop, T number 24 will have less pressure. Meaning in the entire rectangle, okay, which loop had the maximum pressure? This T would have maximum pressure and this T would have minimum or the least pressure. So in other words, which loop would have maximum pressure differential? The first one?
First one,
So you know that more pressure differential means more flow.
more flow.
More flow.
Flow happens because of pressure differential.
Pressure difference.
So the first one has maximum pressure differential, so it has to have more flow, right? Second one has got lesser than the first, so it has got less flow. And the last one is having less or least pressure differential, so that's why it has got the least flow out of these three, right? This is very important step because this problem is very common, water imbalance problem in any operating company for the cooling water system is extremely common problem.